All right, everybody. Well, I hope y'all staying dry out there today. I didn't play any music to begin this video because I thought if it was really quiet, you could hear the rain out there. You hear that? It's storming outside. I might have to build myself an ark and paddle myself home. I don't know. I hope not. I go look at my car. My car's all alone in the parking lot right now because this is my day off. This is President's Day. Oh my God. So I'm here. I got a little grading done. Looking forward to going home, but figured, what the hell? I got some free time. Let's make another video. Maybe someone will learn something and it'll be all worth it. And I wasn't sure exactly what video to make, but I saw I had a video called Trig Functions, and I didn't have a video called Inverse Trig Functions. What the? Can you believe that? Yeah, I'm sure you're like, Mr. Miller, what the hell are you doing? You got a video that's trig functions, but you ain't got a video about inverse trig functions. You're like halfway there. I mean, just do the inverse trig functions, Mr. Miller. Okay. Here I go. Let's do it. First of all, I'll remind you of SOHCAHTOA. Nice little device to help us remember things. Sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent's opposite over adjacent. So those really are our three main trig functions: sine, cosine, and tangent. Now I'm also going to hit you with a little Greek here today. Instead of using the variable x or y, I'm going to go with theta, which is a circle with a line through it there. That's a letter out of the Greek alphabet. Damn! Bet you didn't know you were going to learn some Greek here today as well. So how about that? It's unbelievable. It's unbelievable. So I'm going to talk about theta, but theta is just a symbol. It's just a variable. It's just like x, all right? So let's go get it. So right here, I want to know theta, but I don't know what it is. But I have this ratio of these sides over here. I have this ratio of this opposite side to the hypotenuse. And trig functions are all about ratios of sides in right triangles. So the first thing I need to do is look at this triangle and essentially identify the opposite side, the adjacent side, and the hypotenuse. Because I got to figure out what is the best trig function for me to use. So I usually start at the opposite side. So there's the opposite side. One thing you know about the opposite side is it doesn't make up the angle that you're interested in. It doesn't make up. Do you hear that? I mean, that first little bit about an arc was a joke, but damn, it's raining out there. My God. Okay, so anyways, that's the opposite side. The hypotenuse of a right triangle is always the largest side of a right triangle, which is always opposite the largest angle, which in a right triangle is always 90. And so the opposite side is going to, the hypotenuse is going to be there. And you can, sometimes with that little square, if you just put a little ray through it, it'll always point at the hypotenuse. Which kind of leaves the adjacent as the last one. I always kind of leave that one till last. You could think that the angle is always going to be made up of the adjacent and the hypotenuse. So it's the other side other than the hypotenuse. All right, so now, let's think about this. We've got the opposite and we've got the hypotenuse. So sine is just kind of making sense because it's the ratio of what I got. You see, cosine uses the adjacent with the hypotenuse, and I don't got the adjacent. I mean, hell, I could figure it out. I could Pythagorize that triangle and I could tell you what the adjacent is. But that's an extra step. And why take an extra step, huh? I mean, why step over there if right here is good enough? That's what I like to say. Why the hell am I going to go over there when I could just stay here? I don't want any extra steps. Just tell me the steps I need, Mr. Miller. Don't tell me any more. All right. Got it. Let's do this thing. So I'm not going cosine because I ain't got the adjacent. I'm not going tangent because I do not have the adjacent. So I'm going to go with sine here. So watch this. Where's the black pen? All right, let's roll. So I'm going to go the sine of theta is equal to the ratio of the opposite to the hypotenuse. The sine of theta is equal to the ratio of the opposite side of theta to the hypotenuse of the right triangle. Well, let's see what that is. So the sine of theta, let's go 12 divided by 17. What do we got there? We got 0. All around to 3 decimal places. Let's go 0.706. There we go. All right. So I know the sine of theta is equal to 0.76. But the question wasn't, what's the sine of theta? I mean, I didn't even write the question, but the question, if I did write it, which maybe I should, would be solve for theta. Solve for theta. I want to know what theta is. I know what the sine of theta is. It's 0.706. But what is theta? What's its value? And that's where these inverse trig functions come up and help us. You do this. So watch this little move here. You say, okay, so theta, it must be equal to the inverse sine of 0. I like to leave with zeros. Okay, so 0.706. A couple common mistakes that happen are students try to divide by sine or something. Remember, this is a symbol. These things, they come together. This reads the sine of theta. It's not sine times theta. It's the sine of theta. So now we got theta is equal to the inverse sine of this number. Remember, as we kind of write this, generally it's whatever trig function. So in this case, it's sine. But sine of an angle is equal to a ratio. Or the inverse sine of a ratio is equal to an angle. So it's anytime you're looking for the angle, you're always going with the inverse sines, or the inverse cosine, or inverse tangent. So let's see what the calculator says. First of all, this is kind of a geometry here. When you get to trig, you're going to use a lot of radians, but for now, we're pretty much always in degrees. So make sure your calculator is in degrees. And let's go with, I got to hit the second function. Usually on a calculator, the inverses are our second function. So I'm going to hit this and go inverse sine 0.7706 is 44.9. Oh, mercy me. Mercy me. All right, let's go 44.9 degrees. That is a beautiful thing. And hey, while you're at it, just put a little rectangle around that. All right, we got one more over here. I didn't draw it that big, but I'm sure you can see it. It's a right triangle. This is a 5, and that's a 12. I think right now you ought to hit pause and give it a shot. So let's do it. I'm going to act like I'm writing. I'm going to pause this thing really quick. All right, ready? Hit pause. Cue the beautiful music. Well, I didn't cue the beautiful music. I don't have any real post-production. Oh, I could. 1 second. I'm going to cue the beautiful music while you're working. There it is. All right. Yeah. All right, there it is. Beautiful music cued. Okay, let's go get it. Let's go get it. First thing I noticed, quite honestly, is that I don't have the hypotenuse, which guarantees I'm using tangent because tangent doesn't use the hypotenuse. But I'm going to follow the same structure over here. So first thing I'm going to do is I'm going to find the opposite side, which is the side that doesn't make up the angle. That's the opposite. Then I'm going to go for the hypotenuse. Okay, so I'm going to go up this direction, find myself the hypotenuse. Then the final remaining must be the adjacent. But I also might consider that it is part of the angle, right? That the angle is always going to be the hypotenuse and the adjacent side. So I look at this and I say I got the opposite and I got the adjacent. Well, I might as well use tangent. Like I said, ain't nothing stopping me from solving for h. I could just use the Pythagorean theorem. This side over here is going to be the square root of 12 squared plus 5 squared. But that's an extra step. And like I said last time, I'm feeling a little lazy. So I ain't going to take no steps I don't need to take. I'm going to just go right to tangent. Tangent's going to be able to give me what I want. And we're going to roll. So let's get it. So we got the tangent of theta is equal to the opposite over the adjacent. So I just wrote that just to be probably show way too many steps. Opposite is 12, adjacent is 5. So the tangent of theta is 12 over 5. I'm not going to drop it to a decimal this time. You don't have to. I'm going to say, okay, well then, remember right now theta is an angle and 12 over 5 is a ratio, because a ratio is just a fraction, okay? So then theta must be equal to the inverse tangent of 12 over 5. Well, let me grab my calculator. Let me interrogate this calculator for a second. Inverse tangent of 12 divided by 5 is equal to 63 or 67, 67.4 degrees, which means this is 67.4. And use the triangle sum theorem if you need to find the other one, right? If you want to find this angle, maybe it's y. You do 180 minus 90 minus that, gives you that, and you roll. But actually, I think I'm going to stop this video because to be real honest, I haven't looked at the clock, but I have a feeling this is a lot shorter than some of the other videos. I'm feeling pretty excited about that. I hope I don't talk too long on this closing, but I always feel the need to say that I hope you learned something. That's why I do make the video, and so I like to teach, but I can't teach if you don't learn. And I hope you're having a beautiful day, because we struggle enough out there. We might as well enjoy the process of learning. That's what I say. And I guess I'm gonna start building that arc. Start trying to get myself home. Take care.